Madam to release the conference order. Please, Madam.
Wait.
Thank you, Madam. Thank you, sir. Now it is the time to felicitate our distinguished guest on the line. So I'd like to request Honorable Vice Chancellor Professor Gitanjali Das Madam to felicitate Dr. Priya Kumar Singh sir from Manipur University in Bharat.
Thank you, madam. Now I sincerely request Honorable Vice Chancellor Professor Gitanjali Das ma'am to felicitate Professor Umakanta Mishra sir, retired professor in mathematics, Berhampur University.
Thank you, Madam. Again, I request Honorable Vice Chancellor Professor Gitanjali Das ma'am to felicitate Professor Divagata Mishra sir from BITS Pilani, Hyderabad campus.
Thank you, ma'am. Again, I request your presence, Honorable Vice Chancellor Professor Gitanjali Das ma'am, to felicitate Dr. Subrat Kumar Sahu sir, Arbanit University, Ethiopia.
Thank you, Madam. Respected Professor Raghunath Patra sir, it is our privilege to request Your Honor to kindly felicitate our esteemed Vice Chancellor Professor Gitanjali Das Madam in recognition of her outstanding leadership, vision, and tireless efforts in service.
Thank you, sir. Respected Dr. Pavitra Kumar Jana, sir, I humbly request your honor to kindly felicitate Professor Sukant Kumar Tripathi, sir, Chairman, PG Council, Berhampur University.
Thank you, sir. Now I would like to request Professor Umakant Mishra sir to felicitate Dr. Raghunath Patra sir, convener of the conference.
Thank you, sir. Respected Professor Sukant Kumar Tripathi, sir, I request your honor to kindly felicitate Dr. Pavitra Kumar Jana sir, Organizing Secretary. Thank you, sir. Thank you all. Esteemed guests, faculty members, and students. It is our privilege to invite our Honorable Vice Chancellor, Professor Gitanjali Das ma'am, to address the gathering. Please, ma'am.
Good morning to all our present here. Esteemed Chief Guest, Professor K.P.K. Singh, esteemed Chief Speaker, Professor V. Mishra, esteemed Guest of Honor, Professor U.P. Mishra and Professor S.K. Singh, esteemed Chairman, Postgraduate Council, Convener and Coordinator of this conference, very distinguished guests sitting in front of me, coming from different central institutions. I see many representatives from ICPAM also, and also from other universities and colleges, and research scholars, press, media, and students. It's definitely indeed a very happy occasion, and I congratulate the department to have organized such a beautiful conference on a very relevant topic also. I'm also thankful and grateful to all the resource persons who have come here and who are with us today, despite their very busy schedule. And apart from other places like Manipur also sir has come. So I'm so happy, and Professor Sahu has come from Ethiopia, and I'm really happy, and even to for Professor Mishra also. So they have, I think we were thinking we are having a green campus, but I find one common thing, all of them are coming from a very green land. And it's quite green. Manipur is always famous for its greenery, and also Hyderabad campus. Hyderabad. So I'm very happy, and I'm sure this conference will definitely enlighten the young minds of Berhampur University, the Department of Mathematics. Department of Mathematics, every year they, last year also their seminar was very good, and a year before last there was a Jubilee seminar. It was celebrated in a very great way. I really congratulate the department, and all the students are very sincere, but I feel always, and you have to be very sincere, and a lot of concentration is required, because I am very afraid of mathematics. I was not at all good at mathematics, so it seems to work. So I had mathematics optional, but because of that, my marks went down, I think so. But I have great fascination for mathematics, so because it is a master science, I can say. As rightly it has been told that it is the language of science, but we have to understand the language, we have to decipher the language, we have to really interpret the language in so many ways, if it is a language. And and it is a very important science also, because it's a basic science without which we cannot understand many other science subjects, be it computer, be it AI, or be it physics, or any other biological sciences also. So trigonometry, algebra are always interesting. They are definitely very interesting. I still remember pie chart and all this Pythagorean analysis and all this. We also were having. So in the pure and applied, it's very difficult to actually distinguish between pure and applied. There is no watertight compartment between the pure and applied in any science, or even in social science, we feel. Because theory strengthens the application, and application strengthens the theory. So it is always there is an interrelationship between pure and applied, and pure science, pure mathematics should have an application part. Without application part, any theory becomes meaningless. So you have to apply it to some. It should be used as a tool. So mathematics is always as a tool for to solving different problems, and AI is also it is working on mathematical tools, and we know what AI is doing nowadays. Yesterday I went to Berhampur University. There was a health camp, there was a dental camp. I stood before a machine. They asked me to stand before a machine. So and to open my mouth. Yeah, I told everything. What are the different diseases in my mouth? I mean, what are the shortcomings in my dental? I mean, it's so amazing. But you also know the dark sides. I was saying it is all copy paste. That you go to chat GPT, write a thesis, and you don't apply your mind. So AI cannot substitute your minds, your innovative minds. You must apply your mind, critical analysis. So that is very, very important, not AI. AI can help us. AI can solve a problem, but it should not be a substitute for a creative mind. It cannot be. So, I'm very happy to know that Professor Sahu wants to have some collaboration with us. We are always open to all the institutions, both inside and outside the country. We are having continuously we sign MOU, and we always wish that the MOU should be a functional one, not only in a pen and paper, but it should be a functional one. And we always work upon it, try to work upon it, so that it becomes functional. And our students, the major stakeholders of the university is our students, so it should be beneficial for them. So we are always open for any collaboration or any collaboration and networking with all other institutions. I'm very happy if it is worked out. I would request my departmental colleagues to work on it. And as sir also told that discovery leads to groundbreaking research, it is also true. So only young minds, inquisitive minds can have some innovation. People at this age, we cannot innovate, we can supervise, we can mentor you, but only young minds are inquisitive. So you have to just ignite your young minds. So I'm very sure in this during these 2 days seminar, our students will interact with the resource persons, and they will definitely, it will be a learning experience for all the students in the department to have a career path in mathematics. Thank you.
Thank you, madam, for sharing your affection for mathematics as well as your fascinating comparison between the young minds with AI. Finally, the formal inaugural session is now concluded. We express our sincere gratitude to all our distinguished guests, speakers, participants, and organizers for making this event a resounding success. Now, Dr. Madan Mohan Soren sir will come forward to propose the vote of thanks. Please, sir.
Good afternoon to all. Respected Honorable Vice Chancellor, Ma'am, Professor Gitanjali. It is my privilege to extend a vote of thanks of this historic inaugural session of the first day of the International Conference on Pure and Applied Mathematics. This milestone event will be held in the memory of the Department of Mathematics. We are deeply grateful to our Honorable Vice Chancellor, Professor Gitanjali Dasma, for this year attending today's program despite her busy schedule. Your presence underscore the importance of the quality augmentation in our academic pursuits. We are inspired by your presence, ma'am. Thank you. On behalf of the entire fraternity of the Department of Mathematics and on my own behalf, extend to you a very hearty thanks to the chairman of PG Council, Professor S.K. Tripathi sir, for gracing this occasion with your presence. Thank you, sir. I would like to take this opportunity to express our hearty thanks to our guest of honor, Professor S.K. Sawa from his University, Ethiopia, for his enlightening talk that profoundly enriched our understanding of the subject. His gracious presence and willingness to share his expertise have been invaluable to us. Thank you, sir. We are deeply grateful for your presence as our guest of honor, Professor U.K. Mishra, retired professor from Berhampur University. We appreciate you taking the time to share your thoughts with us, and your contribution to this event have been priceless. Thank you, sir. We extend our heartfelt gratitude to our chief guest, Professor K. Priyakumar Singh from Manipur University, Imphal. We thank you for your insightful presence and favorable remark. They greatly enrich our conference. Thank you, sir. Our sincere appreciation goes out to Professor B. Mishra, Chief Speaker from BSP Hyderabad campus. We appreciate your expertise and time. Your thoughts, remarks, and entertaining presence have profoundly improved our gathering. Thank you, sir. We are indebted to Dr. P.K. Zainab, Organizing Secretary, for his tireless efforts in making this conference a success within a short span. A special thanks to Dr. I.N. Khatro, convener, Ms. Renewal Santi, and Dr. G. Mohanty for their unwavering support for the organization of this event. A very big thank to Devashish Paikrai, Renewal Santi, and Santosh Moderation Scholar for tremendous work in promoting this conference and ensuring its visibility to a wider audience. We value your commitment and support, and your contribution have been irreplaceable. We acknowledge the support and valuable guidance from our respected registers and Comptroller of Finance from Berhampur University. Our gratitude extend to the HOD different PG department, press and electronic media students, and volunteers for their active participation. As we conclude the inaugural sessions, I express heartfelt gratitude to each one of you for your invaluable contributions. Let us carry forward the momentum and enthusiasm into the subsequent sessions, exploring, innovating, and pushing the boundaries of the mathematical knowledge. Finally, but just as importantly, I want to express my sincere gratitude to our cherished students for their collaboration and assistance in planning the international conference. Thank you all once again. I eagerly anticipated the enriching discussion and discoveries that award us. Thank you.
बंद कर चालीस Se habla.
Welcome you all to the International Conference on Pure and Applied Mathematics organized by PG Department of Mathematics, Berhampur University. So the first talk, the keynote speaker, Professor S.K. Sahu, Agamis University, Ethiopia. I would like to request that to please start the talk. I would like to request Professor D. Krishna to start the system. Please start.
Okay, so all of you can come closer. Those who are sitting at the back, if you really want to learn something, it's better to come forward and listen carefully. So let us start this, always, in our occasions, Jatra is over. So let us start the academic part. The first speaker of the day is my friend Sudha. Who will speak, you are talking to artificial intelligence. Okay. Where is he? Okay, now I request him to start his presentation, or talk, keynote talk, and try to interact more with the speaker. Okay, don't be shy. Don't think that you do not know anything, you know everything. In fact, we do not know everything, you know everything. So based on that, so from the super, we will start.
One for it.
Hello. So once again I extend my thanks and gratitude to the organizer and our department faculties and especially our students. So here, as I told that, now we are interested particularly not only technology. Because I told that is no pure mathematics, that is applied mathematics, that is no modeling, so mathematics mathematics. Particularly, we are working so I told that predictive model. Predictive model does not mean that only tiger and the goat. Predictive model I told that before that cancer. Cancer also is predictive model because the cancer cell damage our body. So that is so cancer is the cancer cell is the predator, just like lion, and our our total blood parts are called red. So similarly, there are that means we can work in many aspects.
Zoom. Zoom करूँ. Screen.
So anyhow, I'm very happy. So the title of the topic is artificial neural network or the fluid model. Fluid model means that means everyone will improve energy and particularly I told that this is the part of the mathematical biology and here generally we study two things. One is prey, one is predator. Now you can see this is the decision technology, and now you can say that is artificial intelligence. Then you can say artificial neural network, machine learning, deep learning, supervised learning. There are many learnings are there. So here many people have already worked in the predictive model, but we work that means artificial neural network. The reason is that the advantage that many, even also many professionals in many workers, they mention why to choose artificial neural network. Artificial neural network means we can retry the solution. For example, you are sending your data in the computer. Anytime you can retry. Our university, our mark sheet also there. Your mark sheet you can retry after 7 minutes. So like this. The solution you can retry at any time, any point. So these are the advantages of the technology. So yeah. Now artificial neural network and product is that is mathematical computing system, and we can work in different type of value star model. And I am continuing here. So these are other literature also is continuing here. And it is continuing. So these literature are available. So I am not taking more time here. Okay, because many talks are right. So these were already published recently, so I can share that with you also. So now this is machine learning because we know mostly in engineering students are rapidly finding machine learning, data science, and you are mathematician. We are about this. We are about. That's why I'm going to pay this. That we are about that computer. Computer science computers develop that means program in mathematician. Okay. So you can see that certainly artificial intelligence is very advanced technology, not only in mathematics, in finance, banking, medicine. So this is available here. Proven by project. This is a model. Energy how we can balance. Okay, theoretical model. Okay. Mostly in our places, in Odisha, most of the people are working. So these works are project actually, especially IIT, some people are doing their work, and particularly in Africa and USA and South Africa, fully working in research. So now you can see deep learning, these are available, I was a real time, okay? It's continuing. So where is the impacts are there, okay? So those are interested, you can share this just due to lack of time, so I am just going back. So can you notice this you know? Okay? Yeah, you can see the graph here. One is the prey and one the predator. Predator means lion, prey means maybe goat, maybe whatever. Now, yeah, this is so links and RNA, they are the model, how they are grown, all are the derivative. This is the differential equation, system of differential equation, and that is knowledge of it. Okay? So here are there, and here, that is the main mathematician, they have given the concept since 1920. So here it's very interesting. This the solution of this the differential equation system equation. So this thing I will show you the Python program. And here the students you can that means you do the Python programming advantage what? You are working in no C++, you know many mathematics, but it is the combination of mathematics in C++ where particularly the object-oriented programming, what is not present in MATLAB, what is not present in other languages. So this suppose. So after that I am talking. So if I am interested, I will. So very beautiful, easy to copy particularly. Okay. Now the graphs are there, very well. Okay. So these are the manipulation of the graphs. Rural model. Okay. So these are the manipulation only for this. So you can see here. So this was particularly more they have already worked. So that is motivated by their work. We work. Yeah. So we are mentioning the concept of deep neural network. Okay. Yeah, just this is the literature. So we are talking to knowledge. According to this Chakraborty, they claim that we can find our solution. That is, particularly that adjusting matter. There are some. I know that my work with Professor Misra. So and Professor Mandi, one journal, right? You know what the language? You are only mathematics. That is only question. So I would like to say that is mathematics means you have to beautify that means the beautiful mathematics, not the social media. So he has told that means you are not the adjusting mathematics. Sometimes you can take the help of technology. So these are the full chain model and fully full chain model how we can make the energy balance. Okay, yeah. Now let us come to the main system. Okay, so the prey and the predator. Let you have negativity. The prey may be the lion, predator may be the goat. Okay, but here you can see dx by dt. That is the what you can say prey. Just like you can say goat. dy by dt. That is you can take fox. Okay, so fox eat what? Goat. And another this dj. You have taken. Then many things are discussed on the just kind of demonstrating. This one comment box. Okay, in European journal. And you can see dj is suppose lion and the cow. And that is the last equation is that is the you can say that is lion. Lion can eat. Lion can eat that is wood, and lion can also eat the goat. Okay, so these are the system we can express. Remember, we can express in differential equation, non-linear. Okay, so this is the main thing. Yeah. So here that means we use that means there are many things are there. But actually, before that, I have mentioned here in my mathematics class. So here we have to see most of the thing whether the system is valid or not. So how can so for that we have to check the positivity of the solution. So whether the solution is bounded or not. Okay. So positivity, boundedness, even many books are published in SIU stage, particularly how to solve by bifurcations, by okay many methods that are available. So yeah. So here we are. This is particularly solve the system by Mathematica. And this is the actually this one the first chapter my PhD in this is my first chapter of the PhD in paper published. Now you can whether this is the graphical command and I have already told you J1 J2. Everything is here I told you. Yeah. This is the project. Project of the system. That means you can see prey, predator, co-predator. Means you can see simply I am telling you. Okay. That is suppose goat. Then you can take wool and then you can take tiger. Right. So if the food is not available, everyone will die. So these are the project we have given here. Now the system by element. So here I am telling you this is the particularly input output layer. Even also this concept those are covered C++ programming. Okay, so that is also a concept of data heading and data encapsulation. So this is the also same concept. Yeah. Yes. Now another, because this concept we are now planning for the second paper. That is to obtain the solution of the system by feed forward neural network. There are many things are there. Feed forward neural networks there, and that means many technologies are there. So feed forward neural networking are always some people already know professors. So you can see here feed forward networking. The advantage connected here. The advantage is what? It is solutions are not good often you know complexity here. So this is the algorithm, okay? And algorithm here, so this is the proposal for our second paper. And here that means we can write the vectors.
ये तो पर ऑप्टर रख जे मैनुअल
And this is the simple function, and we can write the vectors in this way. And the hidden that is hidden level, the controlling that hidden level, that is hidden energy, you can say dark energy, whatever you can say, that the hidden concept in our C++, object all are the same concept for this one. Yeah. So here you can see, once again, the graph. Yeah. That means input, hidden layer, output. You not only in the same to the machine concepts are here. Just I'm telling you the concept of hidden layer, you know. Suppose you make the switch on, you light off, you know. But you do not know what is the digital configuration. That is called data highway principle. Okay? So these concepts are here. So what is doing? So that is hidden layer. Okay? So this is the, you can see, this is the procedure. How we are obtaining the solution. Okay? Problem, artificial intelligence, modeling. Like this. Okay. Yeah. So here, what we study here is the system, and we study that means how that means play predictors are affecting. So this is the discussion here. You can see very easily this X. Okay. X stands for the
जूम कर ले
that is prey. Okay. Prey you can say that more than if food is available, they can able to. That is, they can. Okay. So here you can see the graph here. That is food. Food means that is X. X means you can say that is rabbit, or you can say rabbit, or you can say that is goat. And you can see that is Z1 and Z2. We have got Z2. So when the food is going to rest, suppose they are contributing that is roads or whatever. So gradually when that is population less, they are also going to die. So this is one case you can see here. Another case also here. Yeah. So here the graph, what it said, suppose you can say tiger is not there, wolf is there, and goat is there. Then how can you see who is that is after some years? What is the significance of the existence of that player? We have discussed here. Next. So they are the basic concept here. Yeah. Another thing, this is also another very interesting point. So most of the results are the Volkswagen equation. So pulling time functional response. So it's the advantage what? That means that that method slow, but here is the faster method. Okay. There are many things out there who are interested in what kind of problem. Just I'm going ahead. Yeah, this was finally I'm saying that if you are interested, those have basic concept of programming knowledge, they can come, and I have actually told them that this is our basic of our professor, I also did in Berhampur University. 80% we have done programming in our master degree, and I think I have another professor also. 5 students now after master degree they directly join in software and getting USA degree. So I like that. If you are interested, you have the concept. I have seen. So you can also spend software like it's not that in mathematics you are better and better software than others. What? This is motivation. Yeah. So here, this is the program of particularly Python. What I'm telling you, I have done C++, MATLAB, mathematical, everything. But when I come to Python programming, solving the problem is easier. Okay. So these are the initialization of the value. Then you see the program is for only one way and variable. Okay. You can see the program. Okay. So here. Equation first and second equations given, all of them are only arranged. These are what equations are there only. This program is Python program. Okay. Yeah, automatically. So you know mathematical, you know MATLAB. These are not everything. So one second is there. So you can see that is running the Python programming. You can see what the population of limit. Okay. Then you can see another here, growth and analysis. Okay, and together you can see predictor model. You can see the graph. Okay, right? This same graph I have done in the paper, but it was not so much attractive, right? But once we are going to Python, it is better really. Anyhow, this is the evolution, but and our times is very limited for silver less. So I say thank you for all of you. And on this only one. Can you open the second file? Second file are in. Then only for one thing that only one. Just one more. There is a that polish cover. That this is the published paper, okay, of my PhD student, or chemist student. Understand about that? This. Yes. You can just tell that. Yeah. This paper, my student, Ben has done myself and our in the co-author. So this paper, and really you cannot imagine the published paper. We submitted very well accepted in March. Okay, just I'm showing you this thing I have got the here. Those are interested. See the copy here. This is the model you have done. Here positive boundedness. Because you have to check whether the system is valid or not. Suppose you want to from Berhampur, suppose you want to go Bhubaneswar by motorcycle or by car, you have to check whether the car is well positioned to go or not. Whether that is diesel, petrol, support. So that is the meaning of that. When you want to solve the system, you have to check whether the system is valid, whether the system gives you solution. Okay, so for that you have to check the solution is bounded, positive. So like this is okay. So we are calculating here. Existence you have found. So this is the I have shown you. Okay. Now these are this is the distribution of the system. Okay, right? Now this graph I have delivered for you, and it is published. I have told you. Okay. Now, thank you. So it's a motivation. So those are interested, you can continue. And I will do that. Thank you. Thank you. Thank you.
Thank you, Mr. Subrat. In this short span of time, we have introduced this artificial intelligence and its benefit to the students. So, any quick question on you?
Yeah. Anyone can ask me. I will be very happy. Any question, suggestion? Because we especially we work. That means many things I have told that not only paper, but many things you are working also working. So you should get the beneficiary of the time. You can also interact with us.
Yeah, please.
Population, not that years old. I think those are almost the same. Yeah. So that means and yes, sir. What kind of information that you can collect from that particular? I'm not able to decipher the graph that you have shown, and where both the curves are looking almost
Yes,
similar,
yes.
and the peaks are also the same.
Good answer.
So here I am telling you that suppose you can see that question is there, but when the curves are parallel, means sufficient food is available. Sufficient food is suppose, for example, in our local locality, boats are sufficient available. Automatically we can eat. Okay, so that means if you plot the curve, it can go in your problem. But suppose boat is less and the foods are more. Okay, so boat less means our food value also will be decreased. So that is particularly when we are studying that is energy balance. Okay, we are also doing technology also. The energy, the other energy. So everyone is energy.
Okay. Thank you. Yeah.
One major thing I found here, where you find the data, is it real data or existing data?
Here we construct new model. Actually here,
Okay, model is good, but the data should be realistic, or you collect from existing data.
no.
Quality of
That means, for example, here we are creating the model. So here, first of all, that means the model is checked. Okay, whether the model is actually fit to work or not. Okay, first of all, that is our first priority of the mathematical values. Whether the system will work. Suppose you do not say the system will not, the results are very important. So data means here generally according to the that is model, so we can do this.
you consider some data.
The means we can that is for the plan level. For example, let us say because I work in cancer model also. Cancer model also a lot of is required because I have come one professor in Bhubaneswar. I have worked many times earlier. So because I am working in cancer model by artificial intelligence, so he told me you take the what I will do because when he was professor in Delhi, we have the contact now. His professor at MS Bhubaneswar. He is the you cannot say. He told me 12 hours time in doing operation of the cancer patient. Even I related. So yeah, so their data is really very good.
Okay. Thank you very much. And I think there is something from the organizer. Who will offer? You can offer this.
Thank you very much.
Next talk will be delivered by Professor K.P. Singh. I would like to request Professor S.K. Saurabh to chair this session. Please, sir.
So I welcome Professor to give the talk now, and I hope our that means students, colleagues can get the benefit of the talk. Professor, please.
Good afternoon, everyone. Respected chairperson of the session, Professor S.K. Saurabh, and all other respected faculty members and participants. The title of my talk is The Current Trends of Research in Relativity and Cosmology. Highlight. Here in this presentation, I am particularly solving a particular problem. Just I want to share some of the recent trends of research in relativity and cosmology, which we are finding nowadays. You know, the trends of the research in relativity and cosmology is the science problem geography.
It is strengthening day by day. In the earlier time, around 1990, 91, and that one. During that time, the problems solved by our ancient researchers, especially from this state, Odisha, from Sambalpur University, from our late professor Jim Mohan, then from the Nagpur side, under Professor Karate, and from my university, Professor A.K. Tarasam, they were completed together their PhD from IIT Karate. And we are the sixth for those let us pass. And really, I am very happy to visit the Odisha, since it is also the one of the places where my gurus have the relation in Odisha. Anyway, during that time, they were solving their problems directly and manually, finding the solution and just interpretation of the solution and others. Now, is science and technology develop day by day, as you know, better than me, artificial intelligence, many more software like Mathematica, MATLAB, Python, and others are applied, and our research in relativity and cosmology seems to be turning towards the physics field. That's why many controversies are there among the association for physics and mathematics, like the National Society of India, then IHRG and others. Opinions are different with mathematicians and physics. Here I am sharing some. You know our relativity. Then when the Einstein developed the general theory of relativity, then it is not from the foundation of Newton. Then Newtonian mechanics, as you know. Table contains the presentation, introduction, some modified gravity model and solution for some particular problem, which is under review for publication in the Journal of Astrophysics and High Physics. And here, future prospects in relativity, some cosmology, Berhampur, and the company. You know, human beings are most involved in thinking creation in the world. So it is our moral obligation to learn about the unknown aspects of the new scientific tools and techniques developed in the new era, which we are facing today. In this new paradigm, emerging technological capabilities often lead to deeper scientific understanding, which is turn without new opportunity for further technological advancement. The scientific world is a turning point. The weight of the knowledge, the technological development, and the possibilities of revolutionary breakthrough have never been stronger. In current trend of research in science, mathematical tools like Mathematica, MATLAB, Python play a crucial role in achieving efficiency, accuracy, and solving complex mathematical problems. And lastly, we can use the development and opportunities of the artificial intelligence in our research. So current students and research scholars, from my view, needs to know and handle their tools to perform research work effectively and to have a good competition in the international journal. This is my simple opinion, and what I am sharing to the young research scholars who are participating here. You know, from the concept of Newton, Einstein developed this general relativity, but what is the difference between these two concepts of the Newton and the Einstein? Simply, it is a basic thing, that means Newton study about the laws of nature to the mathematical equation based on the four fundamental things: space, time, matter, and energy. But from the concept of the Newton, which are considered absolute and independent. Whereas in the case of Einstein, he studied about the laws of nature to the mathematical equation based on these four fundamental things: space, time, matter, and energy. But in the concept of Einstein, it is considered as absolute but dependent on this. So it seems that Einstein, the natural relativity, it is comes from the Newton's concept from the absolute raised to relativity. So what is relativity? We are familiar with us. That means it is simply the Einstein theory of gravitation. And cosmology, it is scientific study of the origin of evolution and state of the universe. Therefore, I am sharing that this basic definition, since some of the participants are not from the planet group. What is the importance of research on relativity and cosmology? Mainly, this is the link between physics, mathematics, and the astronomy, and to understand about the universe from the cosmology. The theory of general relativity is developed around 1915 Einstein revolutionary theory of space-time curvature. Then some of the milestones other than the Einstein general relativity is Hubble's observation of expansion of the universe, 1929. One of the milestones in our research, discovery of the cosmic microwave background radiation, CMBR, 1965. Announcement of the gravitational wave detection by Weber, 1970. Dark matter and dark energy, 20th century. There are some shifts and very common to all of us, accelerating and expanding universe basis and at the their publication in 1998. These are some of the milestones in the general relativity. And the current trends of the relativity which people are doing nowadays: gravitational wave astronomy, black hole physics, modified relativity. And the area which they are doing mainly are between with these spots. They will do that point. Then in cosmology, we are discussing dark energy, dark matter, large scale spectral formation, primordial cosmology, in which the inflationary theory understanding of initial condition of the Big Bang, cosmic microwave background studies, and these precision measurement for the satellite, which are some people are doing now. So, intersection and similarities between these relativity and cosmology, testing of general relativity and modified relativity and cosmological sphere. And gravitational wave is a probe of the early universe, cosmology with the black holes and exotic objects. So, we are familiar with the Einstein equation, that means which is given by this equation and symbols have this meaning. You are familiar with mu is the curvature tensor, is the scalar, the mu metric tensor, and the theta. It is common to all of us. Here, when we study about this one, after developing this Einstein field equation, when we study about any mathematical model or cosmological model, we consider a particular metric or a line element. It we know. Here, many forms are there. FRW metric or sometimes commonly the FRW, and now It is in the four-dimensional case, r theta phi t, spherical symmetric line element, especially which we are considering in the wormhole, and then geometry general form is here, but if you know, in geometry, it has a different form. I'm sharing some of them, like you can theta 1, then theta 2, 3, then theta 4, 5, and 6, then 6, 8, then this then theta you can use, and this line element you can find from our literature. And then considering any of the this metric or line element is for your topic or target, then what we are doing, we will study, consider the one image momentum tensor, either maybe for a partial fluid and a viscous fluid. But we know commonly people are studying in the partial fluid. But we know we should attempt to study in viscous fluid in well electromagnetic fluid flows. Then here, this is electromagnetic image momentum tensor, and here the symbol here mu is this electromagnetic field strength tensor, you know it will become permanently, and then viscous fluid, it can have this form, you know it, and then for velocity vectors, you can find out it, but you know in the case of the have dimension also, we can find out the velocity vectors with respect to the ordinary manner. And we have discussed it on this one. This going to the energy density, this one, this is form, but you know, when some of the terms become zero, it will take the 100. And the two fluids energy momentum tensor, we are familiar here. They mean the one with matter, another for the dark energy, and having the different this one form. Given in the equation 8 and 9. And after the Einstein, and many scientists are trying to develop the modified theories. And some of the common modified theories which we are using is this one, relativity, scalar tensor theory. Among this one, like Grand-Decay theory, then there is this theory. Then one of the most prominent skills to address the dark energy content issue of the universe is the modification of general relativity or the F theory of relativity, where R is the after the development of this F theory, some modified theories like F theory, FRT, FRL, some common gravity theory, FRG, FQ, FRLT, FQC, gravity, restored gravity, magnetic gravity, and the rainbow gravity, many more. Just lot of topics are here which we can study. And nowadays, even respected Professor Mishra and his team are doing some of the work in FQ and FQC recently. I saw from their recent publication. So we can consider this one, and if for that any particular theory, you can collect your literature and you can find the formalism of their development equation, and then you can attempt to find out the solution manually. And if possible, if you have the idea for using of Mathematica, then you can use the Mathematica and compare with your manual solution. Then actually you can find out the parameters. Then some modified theories here. Cosmic acceleration in accordance with the different cosmological flow has been quite related to the theory of relativity. And the derivation of the theory of relativity, however, is approach is mainly hunted by the cosmological constant. So problems for that alternatives are such. Main alternatives comes from modification of relativity for a couple of relativity theories. Here I am considering only two particular theory, and just to share with you, one is the F of gravity, another is the F of relativity. You have seen F of gravity has a form like this. This is the action of the FRT, and it was developed by the Harpo and you know, around 2011, reference is given here at the bottom, and where f is an arbitrary function of the scalar r in the case. T of the unit momentum tensor and T is in the form of this one. Then PID is the unit momentum tensor for this FRT 50. It is given by equation 11, and where trace is given by this. P is equal to GIK. Then assume the metal aggregate density Lm is equal to minus T, depends only on the components of the basic tensor, Grj, but not their derivative. Then we get equation 12 and the variation equation 12 with respect to the Grj, then we can find this equation number 13. And this theta ij is equal to this one minus 2ij given by 14, and here FRRT is given by this. And this with respect to the FR. And constructing the equation 15 given earlier, we can obtain equation this one, equation 15. After construction, we find in this form. And you know, for this particular FRT derivative, are co-equal the whole these three forms of the model. FRT is equal to these three conditions. And then out of this, here we consider only the first one, FRP is equal to R plus Fn, and choose Fp is equal to alpha T, and then we are calculating, and then from this values, substituting into 19 into the 15, we get equation number 19, and to explore the current cosmological model, under this formalism of the FRT, we consider the one of the FRT will be 3. This one, this is equal to dt square minus kt square divided by 20, where kt is nothing but your and calculating non-zero components of the Christopher symbol for that metric, then we are finding these values, and finally the scalar r is formed by equation number 23, and I is the whole parameter. That is what is given by A or sometimes R not by R. And then the stress energy momentum tensor corresponding to the line element 9, question number 24. Then modified Newton equation which describes the universe dynamics in terms of the part is given by this equation 25 and 26. And then by expressing the energy density and the pressure, it is a common process what we are doing in the range for relativity. And then have an equation can be written in the form of 29 and 30. And here what we need is text value alpha into rho minus 50. And for that energy density, text alpha into 50 minus rho. Then what happens? Question of state parameters for dark energy is calculated, and we found it 31, and using the I naught is equal to minus I into 1 plus 10 into the into 22, then we find the question of state parameter for dark energy like equation 32, and then the dark energy model with the FR derivative can work. Focusing on the two one is the parameter. Characterization that these are given by 3 and 34. It is with reference to this reference given in 5 and 6, where the only the parameters W and W are constant, and here we consider the two model of this parameter defined by I is equal to A naught by A. For a model 1, I get is given by equation 36. For the model 2, by 37. Then we have some analysis we perform. Is other researchers are doing that one diagnostic analysis the behavior of functions suggested by the Sahan and the Hesselian classification of the positive dark energy condition from the universe to the special homogeneity, the one diagnostic function defined by equation 38, and then where I should the current house parameter I is there. And here coincidence concept is indicated by the negative slope of the OMZ from the this one that can be seen in the next figure, where the control motion is indicated by the positive slope. And the constant OMZ is still for the relativity model for this particular model under the formalism of the relativity. Step under analysis, we calculate with I is equal to A naught by A, R in S, and this one, sine unit and the stage of the universe calculated from this formula given by 40, and then to study the observational constraints and cosmological applications. Nowadays, a list of the Hubble measurement in the redshift range 0.7 to 1.96 was compiled by the Steve Fonda and the Stein, reference number 9, and by using the data, and then we attempt to estimate the model parameters in question number 41, and so data is here. This is cosmic chronometer data set. So we are this is data set, and then analysis of the I is done with the use of the Python, and then this confidence level contour plot for model 1, and when the CC data is drawing like this. Here you can see the low time is 67.02, then W naught is like this, and we found radiation like this, and similarly, this is for the model 2. We have presented under this CC data, and then the relation parameter is defined by this relation, which are similar with our equation number 42. Then for the model 1, we found out the relation parameter Q and another value of Q for the model 2. We calculate this are given by 43 and 44, and equation of the step parameter, and this is for dark energy. Characterize the relationship between the pressure and the density for the dark energy. It defines the WdE is going to be dE by rho dE, where the density and V are nothing but the density and the pressure. And for our model, we found it in question number 45. And so here, this is the for the values of the present values of the Q with respect to the model 1 and 2. We analyze one. This one two color one is for the model 1 and another model color is for the model 2. But one line is there between this one, and that is it divides into the two phases, one for the accelerating phase and another for the accelerating phase. And here values are minus part, generally this region is for accelerating and another is decelerating. And the point where this graphs intersect, the line, horizontal line black in color, which is intersect at that point. This is nothing but ZT transmission value of redshift, and for the one is for the model 1 and another for the model 1. It is found to be 0.67305, and that of the model 2 golden in color, the value of the redshift for transition redshift, it is found. These two values are almost same. So here, this is the variation of the equation of step for dark energy and the matter separately to present, and then model 1 here. At present, Z is equal to 0, phi equal to 1.013, and then we found it with respect to the CC data, it is shown to be 0.657, and here of the model 2 is minus 0.01. The value indicates that based on the observational data, what the models based equations like that magnetic behavior, it is the uniform. So where this equation is the parameter for dark energy lies equals to -1. And another formalism I am showing with respect to the FR okay, and this action is taking like 46, R is getting in this way. This is the one more formalism, A for alien, but now people are doing another formalism, A for alien theory. So, yes.
Excuse me, Professor. Can you repeat my findings?
We are trained is earlier, etc. So, here, for this second one, then we know that what particular equations involved in two independent equations if we are not. So one of the common ways we can take much in the Western literature is to suppose a free solutions for scale vector directly or by means of the cosmological parameter, and I follow the suggestion given by these references, and then we will find out the Q, this one, we assume the QA in this form 61, and then finding the ISP following the Hubble's parameter is equation 62, then create the solution. And here we investigate the implications of the assumed QB parameter. That is our supposition of the solution parameter in cubic form, and under this formalism, and then we know this after this assumption here data analysis and proceed. This is to find best fit values of the derived models of the employing this Markov chain Monte Carlo technique, and the valuation for function this one we assume under this one we are presenting presentation best fit plots of the parameter I not gamma delta with these two errors I z, and we found here this. That means here I scored 69.907, and then other values are taking care to get that about our figure. And so, and also we are using the printed data set like this, and here is this one, still the year of that is this model, and basic plot of the parameters from the region, and we use the two kinds of data set, I Z and the question. In this case, we will say this is the combination of the two set of the sample point in this way, and then again we are presenting like this, obtained from the BO, and then I Z plus BO plus taken data set analysis together. Like this, and basic plot of the parameters under this is presented here, and you know with different colors it is showing one for view, one is indicated for this particular figure, and we are using 61, 63 to calculate the QZ. That means earlier we assumed that cubic one, and then analysis of the distribution parameter is green. Above the horizontal line, which is black in color, distillation phase, and then acceleration phase, and then for the different data set, we are presenting this one. But some of these figures are lines are collided with one another, and it cannot be visible. So my last point, this one, in my conclusion, is that what I would like to suggest to you. When we presently doing the research in the field of relativity and cosmology, in this current range of research, mathematical tools like Mathematica, MATLAB, Python play a crucial role, achieving efficiency, accuracy, and solving mathematical problems. So our students and research scholars need to know and handle this tool to perform the research effectively. For a good publication, endless pursuit of the understanding of our cosmos and future prospect, new observations, deeper questions, interdisciplinary approach and work in this research. And so, my recent publication related to this, one for 2025 in the Journal of Physics with my research scholar, and another 2024 in physics scripture, and then another verification in cosmology, then one in the Journal of Scientific Research, and another physics scripture 2024, and this is modern physics letter A, and this one is European Journal of Physics. These are some of the journals is standard and what is required. These are the differences which I use to all.
Thank you, Professor Singh. Beautiful talk. And I hope the students and the delegates and the faculty members so once again, thank you, Professor Singh. So beautiful talk. Really working in this direct energy and so anyone interested can ask questions or later you can talk to Professor Singh. Anyone? Questions? Yeah. Yeah, sure. Ask. Give a mic. Yeah, sure.
Hello, sir. Actually, I have a question. How you simulate the data as like PAO, XZ, and everything? Combine the data to study the model.
Actually, before this, they minister through the online. Some of the data is there already, and we can find it together.
That means already.
But actually, you know, to use the data, you have to have the basic concept for your Python and the sorting of the method. But actually, we are not preparing for this thing. If you know when we prepare about a manuscript to publish in a particular journal, they have some campaign of the journal. You see, and where we are putting our solutions and like they have their own data set, which is available on website, and this for this particular collaborative works in the big collaborative service, very well. So they keep this in their own website. That means all the data set what they are finding, they do not hide nowadays. It is shared to their own website. That means that some team of the members combining of the 20-30 people, and it is highlighted from there. We can download, and where is our finding, we have to keep it. Sometimes accurately may not be found in the beginning, but just presenting here and there, then actually we can find it. But this data, without using this data set and the software, we cannot analyze it. Because otherwise, I mentioned earlier, without all these things, we cannot promise you. Following some stuff like the social Mishra, social application, and then many more American products in India, and in Nagpur, Maharashtra, and Odisha. But really, I'm proud of the people of the Odisha. That means they can start everywhere and they are doing good duties in where they are serving anywhere in India, and then they have other this people of the Odisha are working people, and then a lot of things and many of the examples, they are in this session. Thank you all.
Thank you, sir, for your contribution. Sir, one of the things you say about your modified theory of chemistry. Sir, in this like L30 theory, parameter theory, so how can we choose the parameters that will keep in the modified theory of chemistry? Means how can we choose that this parameter will be means by taking this parameter we can create another modified theory of chemistry.
But once you can consider, for example, you might, if your topic is particular line, you can decide 3 or 5 or 6 what
number of
Means we can take only the formalism given by the what we put formalization
extension of this apartment.
Other Chinese constants. So, still,
It's not actually coming to models, you often the years minus 0.68 and around minus 0.8. Observation mostly favors around minus 0.8. That is a both calculation and the observation most of the mostly observation machine after you exercise
we will discuss later. If you have some questions, we will discuss.
anyhow, Professor Singh, very nice presentation and very good questions. So time is very less.
Hello. Next talk will be delivered by Professor Dimishra.
I would like to request.
So, first, this is someone going to chair the system.
Yes, sir.
Okay. Then are you able to everyone? So I want to begin not on the dais. Okay. So we have already listened to two people. One spoke about the artificial intelligence, another one about the. I said remove this. So now it is coming. The cosmology and relativity. All of Anyway, in the meantime, how many of you are feeling hungry? Actually, I am feeling hungry. So the chairman has told me to speak only not more than 30 minutes. I'll try to introduce something here. The recent problem of the universe. And what is the relevance of the mathematics there, in specific the geometry. So you can see the title is Late Time Perspective Phenomena, Role of Cosmology Gravity. I started very fundamental. This is mostly the overall picture, but I don't know how much I will be able to cover in this 30 minutes time. What about the present universe? Why do we need to modify the general relativity? There are some questions to the previous speaker. I'll try to clarify that. The third one is the cosmology gravity. What is the beauty in this gravity and what is the relevance to mathematics? The cosmological observations, my friend has already introduced something. I'll give more about that. And finally, the dynamical system, but I will not talk the dynamical system. I will not speak few of the words. You know this gentleman, Albert Einstein, and at the initial stage of his thought process about the universe, so he told that the universe appears to be static. Means wherever what is there, they will remain like that. But it is not the case. So, where is the control? Is the control? Okay. So, now you can see these two pictures. The upper one is very flat, and the bottom one, you kept some mass on that. So there is change in the shape. You take any 2 points. For example, you take a point here, then you take another point here. Then you measure the distance. The same thing you do it here after putting a mass on this on the surface. So that is why mathematics says gravity is related to geometry. And the this mass that causes the space-time to curve. You put on some mass on that, then the shape of this surface got changed, become a curve. The third one says gravity is not an instant accelerated distance. And what Einstein has thought out that the universe is infinite. Now you see, if you are reading from one point to another point, so let us take an example. You are going to a rooftop, keep on walking on the rooftop. And if you keep on walking on the rooftop, certainly you fall after some time. The same picture you can see in the top one, there is something called electric. Now, these two equations are already solved by the previous speaker. Here you can see this z mu nu equal to 8 pi g by c equal to e mu nu. The g mu nu is from the geometry. And we are not discussing much about the right hand side. That is mostly my physics friends will do that. That is the matter. And when you start about this relativity of cosmology, you need to have some amount of knowledge about the tensor calculus. You know about the ordinary derivative, partial derivative, but here you need something beyond that called the covariant derivative or the covariant derivative. Therefore, I think we have noise here. So, if it is fine if I can speak without any mic? Yes, sir. Okay. So, this is the first equation on our universe Einstein has developed. One side is the geometry, another side is the matter. And in this geometric part, the first thing that has come out is the curvature. And you know, the deviation of the curve from the tangent line is the curvature. So that curvature, based on that curvature, the Riemannian curvature has been developed and the Einstein field equation has been placed. It says further, so now I make a pause here. So all of us are aware about the Einstein general theory of relativity. And the first idea has come up that it has been originated from the curvature of the space-time. what is the space and time? You know the distance between 2 points. We need a formula y2 minus y1 whole square plus x2 minus x1 whole square. It's valued if it is a 2-dimensional geometry. If it is a 3-dimensional geometry, you take the z-axis. But when the distance is to be measured through the curves, again some noise. Right? I have removed the mic now. Switch off the mic at least. So when you are taking the distance through a curve, in that case, our distance between the 2 points through a straight line will not work. Then we have to get into some kind of functional form of that. And the change that is happening from one point to another point, the value of the coordinate is also getting changed. Therefore, the space and time is related to the coordinate. Change in the coordinate, x coordinate, y coordinate, and the z coordinate. Now, what happened in 1998? There is a remarkable change about our understanding about the universe. It is very simple. So you see a galaxy is glowing, but this observation, known as the supernovae observation, it has been revealed that the universe is expanding. Like they are blowing a balloon. So when they are blowing a balloon, it is expanding. If you have put a dot at the beginning of the surface of the balloons and keep on blowing, the dot will further enlarge. What happened here in the case of your supernovae observation, they have observed several galaxies. And it has been observed that the galaxies are getting fading away. So you just imagine you have one ball is glowing. When you are going away from the bulb, the light is gradually going down. Therefore, it has been revealed that the universe is expanding. I think I find it. I mean, in light. If you need anything else, then okay. Further, it is not only expanding, but the expansion is happening in an accelerated way. Then the entire community working on cosmology, relativity, etc., came into standstill post 1998. Where is the issue? Why the universe is expanding? And was something has been revealed experimentally, the mathematician has an issue. How I prove this mathematics? Or what is the wrong in the geometry of Einstein's general theorability? So, the supernova are bright enough to be seen everywhere in the observable universe. There are certain observations made post 1998, starting from supernovae observations, and how they do this. Again, by the Hubble telescope. You know, 1928, Hubble has started this Hubble telescope. It's a remarkable research. Now, again, with the modern technology, it has been revealed that the universe is expanding. Further, this is a simple case. Now you observe this picture. Here you can see, just I put some curved line in between. What is your balloon is going up and up. The distance between 2 points is getting increased. Hence, the universe is expanding. The universe is experiencing an accelerated expansion. And further, another problem came into mind. According to the earlier knowledge from the Hubble telescope, the present age of the universe is 13.82 billion years. And 1 billion year is equal to 10 to the power 9 years. So, if the rate of expansion is constant, we mathematicians are very clever, we can able to make some formula to find the rate and the age of the universe. So, from here I can just pass on some recent problem. Different cosmological observations are providing different age of the universe. You cannot have a two age. But earlier it was there because I have one age for certificate, one age for this from the horoscope. But nowadays, It is not possible, and universe cannot have multiple age. Since different cosmological observations are suggesting different age of the universe, this is another research problem leads to H naught tension issue. This is a tension really given to the scientific community. So, moving forward, it has been revealed that 68.3% of our universe is filled with dark energy, and the research says there is something unknown form of energy or the exotic energy is responsible for this strange behavior of the universe. And 68.3% of the universe is filled with dark energy, 26.8% of dark matter, and whatever really we are experiencing or working is the 4.9% of organic matter. And this distribution of mass energy budget of the universe also differs from one observation to another observation. So, in this cosmology, astronomy, dark energy is an unknown form of the energy that affects the universe on the larger scale. What is the issue? What is the problem? How to remove this? So, one possibility I can see that because I told you that there are different age cannot be there for a universe. Similarly, different cosmological observation, the Planck collaboration gives into post 2013. This is the most This is the most not most updated, some new H1, and this is before Planck. This WMAP will give some microwave anisotropic probe. This is another kind of observation which given this mass energy budget of the universe. Then which one really need to believe or trust? The question lies there. So, dark energy, starting from the Big Bang, different phases of the universe are there, irradiation dominated phases, matter dominated phases, and this phase is the dark energy phase or the de-Sitter phase. So, what is this dark energy? Or is there an extra dimension to the universe that leads to the string theory? Or principle, if I go in a very fundamental question, none of us know what is this gravity. We do not understand as of now. So especially, at a long range. So this is one of the one beautiful picture of the Big Bang, inflation, expansion, and present day acceleration. So, Einstein's general theory of relativity is in danger. But there is again a remarkable, groundbreaking finding on the merging of black holes, formation of gravitational waves. So this gravitational wave, it has been revealed on 14th September 2015. It further supports Einstein's general theory of relativity. One way we are telling there is some issue in the Einstein general theory of relativity. Another way we are telling the gravitational waves astronomy is suggesting GR is well formulated. But Einstein's general theory of relativity needs some modification. Then how to modify this? We cannot move it on hand. What kind of modification we need? So I've shown you one equation of Einstein field equation that is called. Either the modification can be done on the geometry or the modification can be done in the matter. My focus, being a mathematician, wants to make some modification on the geometry and try to follow some of the literatures. So these kind of modifications, I'll come to this later on. These kind of modifications can be done in three approaches. One approach is the curvature approach. To any gravitational theory, it starts with an action. Like in the case of mathematics, it starts with a function. Let y is equal to f of x. Similarly, in any of this gravitational theory, it will start with an action. One action sample you can see it there. What does R suggest? R suggests the curvature. Instead of taking a R can I take f of r, the function of r, such that f of r become r square plus alpha r? Possibility in my other slides. So instead of simple r, the curvature, it is known as the Ricci scalar. It can be a form of r that is guided by a function, or a map you can make mathematically. So the modification is done. Now it is not only r, you can take any form of fr and make a kind of set or modification to Einstein's general theory of relativity. The first among them is Alex Starovinsky, a Russian cosmologist who has done on this. And we are fortunate to meet him multiple times at Moscow. The second approach, you know what is torsion? Torsion, three-dimensional geometry, T and B frame, tangent, normal, binormal, three planes, normal plane, rectifying plane, osculating plane. So one object is moving. How much it is deviating from one of the plane, that leads to the torsion. So what actually done during the same time, that general relativity, then in place of this r, some tetrad has been given. The tetrad is based on the torsion. So incorporate the torsion, and that leads to teleparallel equivalent of general relativity. The third approach is a non-metricity. So take a curve. This is my base. The curve is taken here. And you just put some kind of line from this plane, and where it touches the curve, obviously the length of that line is different, leads to the parallel transport. And that approach is known as the non-metricity approach. The non-metricity is nothing but covariant derivative of metric tensor. Tensor is nothing but a combination of vector and scalar. So with that, the three different equivalent geometry has been made: curvature, torsion, non-metricity. They are equivalent. All the base is different. One uses curvature, one uses torsion, the third one uses non-metricity. Moving forward, the modification has been done from general relativity to some FR gravity, teleparallel gravity to some FT gravity, non-metricity gravity to some FQ gravity. Are they equivalent? No. When they have made any modification, in order to make their modification equivalent, some kind of boundary term need to be incorporated. Then only you can say that these three modification gravity are also equivalent. So from F, there are FR, FRT, FRLF, many more my friends have already shown this, including of some additional method term or the geometric term, they made it. But some of this theory came, made some bombarding thing in between, and simply they were obsolete because they are unable to address the present situation of the universe. Like someone is telling about FRT gravity. No, it is almost outdated now. So now, like that, one such example, I would like to place it here in the FZ gravity. I am not going to tell about what about the research. Some explanation to this. You must have seen in a topology Gauss-Bonnet invariant. We are using the same Gauss-Bonnet invariant here. And this Gauss-Bonnet invariant is used with respect to the curvature. These are the very mathematical formulas where one can get it. And do remember that every gravitational theory has a kind of set of equations. It starts from the action with many things. Actually, there are ways, I think we conducted an IIT sometime now, how to calculate the field equation from the action and how to solve it. So, these are field equations. Can you imagine how many terms are there? This mu is nothing but representation of this four dimension, x, y, z, and the time, space time is t. So 0 represents for time, x for your 1, Y for 2 and Z for 3. Once you represent this, then you have taken care of all these dimensions according to the time. So this field equation will provide you a set of equations once you put a kind of space time. Another thing you can see is AT. This is nothing but the factor of that dx square plus dy square plus dz square. What does it signify? What kind of, that is not the scale factor, the expansion factor. So if there is making any change in any of these spatial coordinate, spatial, S-P-A-T-I-A-L, that represents x, y and z together, the changes is happening uniform in all directions. That is why it is called an isotropic metric, or isotropic space time. It leads to a set of equations. Now you can see a set of equations. In Einstein field equation, the left hand side will be there, right hand side will be there, but here we'll have some more number of terms on the right hand side. That gives rise to a kind of, you see, this is the extra term you can get in the case of your modification that is made to the Gauss quantity invariant. 5 minutes more, okay. Okay. Anyway, okay. I'll try what more is there, but now you see what the modification. The modification that is done by Einstein's general theory of relativity is shown here geometrically with the help of the Gauss quantity invariant, that these are the additional term we are getting, and these are going to address the present behavior of the universe that quite expanding. Further, there is some mechanism, simple mechanism to test all these things. I am not going into the details of this. We want some form of Fg, that is also challenging to find out some form of Fg. So since it is 5 minutes, I don't know what I will do. But anyway, to solve the system, from our basic class 11th, 12th, number of unknowns should be equal to number of equations so that you can get an exact or analytical solution. But here there are many unknowns and only 2 equations. But either you have to take some condition. Now, what the cosmological observations my friends was telling, and I also replied to your question, Professor Tripathi, whatever you asked about the cosmological observation, that we do not solve it analytically. It is possible. We will consider some form of the scale factor that leads to the Hubble parameter, and then finally we will get some form of P rho and what is this, AT or something. Then the different geometrical and cosmological parameters come. What actually we do, in the very present one, we take the numerical simulation of this equation directly with the help of the cosmological data sets. And what the value problem was we are telling on that time, normally what happens, there are different kind of cosmological data set available in the literature. The most recent is the Desi data set. Dark energy spectrometer, dark energy spectroscopy instrument, the 2024. That is the most improved version of this supernovae. It gives some 1701 data points. So that data points we invoke and we introduce it here to find the best fit value for the cosmological parameter of the question that you are asking. So cosmological parameters, either you can check manually one by one by doing the hit and trial method, but in order to confront your outcome to the cosmological observation, you need to invoke those data and put in here, then you can get that beautiful color plot what I was showing. But one thing you remember, in the normal computer or PC, you can only go up to 1000, 2000, maximum 10,000 iteration. But the beautiful, the appropriate solution will come when it will run for 1 lakh iteration, and that 1 lakh iteration is possible only in the high performance computing facility. It cannot be possible in our normal laptop account. That is why there is some variation in the value that we are getting. I don't know what else speak. We are different things are already here. Very difficult for you to understand at this learner stage. Those who wish to learn more, be in touch with me. Not going to tell all these things. No, it will be more technical to you. Dynamical systems are only 2 sentences I'll tell on dynamic systems. We'll make certain consideration. While solving the system, you are making some consideration. Whether the consideration is appropriate or not. The dynamical system analysis will check that. And while they are doing that, you'll identify some points. Not the fake portrait. You'll identify some point, like a black point here. Have you seen this? See, all of these are not pointing towards the dot. Some are coming, some are going away. So it is not stable. If I can able to find out a point where everything is coming to that point, then you can say that it is a stable point. And in the research, the stable point should occur in the present era of the dark energy era. Yeah, this is one such point you can see. That everything is pointing towards the black dot. So it is a kind of stable solution. Okay, leave it. Yeah, this particular is published in one of the top journal monthly notices of the Astronomical Society, where my students Santosh said down and I was talking in my inaugural meeting. What the idea comes from the young mind. The idea came from my student, PhD student, and one intern student from Berhampur. So he worked with me for the summer, and we made this one of the top publication, and something very, this is an institutional obligation. Any JRF wants to work with me, they can write an email to me. If you want to know more about me, my webpage is there. I am here up to tomorrow lunchtime. If you want to read more, I am ready here. I wanted to speak a lot of things, but chairman is literally telling me 5 minutes, 2 minutes like that. So I am sorry, I do not speak much, but I love to speak to people if you need anything from them. Thank you very much.
Maximum, we can take 3 questions.
Don't give 3 also. Why are you giving 3?
Okay, from our behalf, I know you can ask several questions.
So let's thanks again to the speaker.
Thank you very much.
Now is the time for launch. I am inviting you all to the launch. You are in your department of physics ground floor. So I request you all to join the launch. Thanks all. After the launch, you will join. You have to, I request all the students after the launch. You have to call your new conference again. Okay? Join us after the launch.
Sorry? पूरा पर्टिकुलर नंबर से सही जाता है ऐसे सत्य सत्य से तो सही पूरा नंबर 3 है
सर कितनी पर
यूनिवर्सिटी अलुमनी स्वाधीन सर को ग्रुप
लॉन्च
ರೇಣು
କଣ କରିବୁ ଏଟା କେମିତି ମାନେ ଟେଲିକାଷ୍ଟ ଏଟା ଲାଇଭ୍ ହଉଛି ଦେଖୁଛନ୍ତି କେତେ ନମ୍ବର ଆସିଲେ ହଁ ତ ଦେଖିದ್ರೆ କଣ ଟେ ଆସିବ ବସୁନ ଏଠି ୟୁଟ୍ୟୁବ ରହିବ କେତେ ଲାଇଭ୍ ଏଠି ଦେଖ
କିନ୍ତୁ ପୋଜ ଦଉଛି ଦେଖିଏ ନା ଭଲ ନମାଜ ଅଛି କାହିଁକି ତମେ
ଲାଇଭ୍ ହଉଛି ଟେଲିକାଷ୍ଟ
ଲାଇଭ୍ ହଉଛି
ଲାଇଭ୍ ହଉଛି
ଲାଇଭ୍ ହଉଛି ସମସ୍ତେ ଦେଖୁଛନ୍ତି ନା ସେପଟେ ଲାଇଭ୍
ଦିବ୍ୟ ଅଫ୍ କରିଦେଲି ଏଟା ଦିବ୍ୟ ଅଫ୍ କରିଦିଅ
ମାନେ ୟୁଟ୍ୟୁବରେ ଯୋଉମାନେ
ଭାଇ ଭାଇ
ସମସ୍ତେ ଦେଖୁଛନ୍ତି ଲାଇଭ୍
ଏଟା ଜୁମ୍ କେମିତି ହବ ଜୁମ୍ କେମିତି ହବ ଏଟା ଜୁମ୍ କେମିତି ହୁଏ? ଏ କ୍ୟାମେରା କାହାକୁ ଅପରେଟ କରିବା ଆସେ? ଟିକେ ନାଇଁ ଏପଟେ ତ ଗୋଟେ ପଟୁ କର ଏପଟେ ରହିବନି କଣ ଏଟା କଣ ସମସ୍ତେ ଦେଖୁଥିବେ ଜୁମ୍ କେମିତି ହୁଏ କହିଲ? ଇଏ ଯାହା ଭାଇ ତୁ ନା ମତେ ପଚାରୁଛୁ ମତେ କ୍ୟାମେରା ମୁଁ ଏଟା ଫାର୍ଷ୍ଟ ଟାଇମ୍ ପାଇଁ ଆରେ ଏ କ୍ୟାମେରା କାହାକୁ ଅପରେଟ କରିବା ଆସେ? ଏନିୱାନ୍ ହୁ ଇଜ ସ୍ମିତା ବନ୍ଦ କରିବା ପାଇଁ ସ୍ମିତା କୁଆଡେ ଗଲା? କଣ ବନ୍ଦ କରିବା ପାଇଁ ନା? ସ୍ମିତା କୁଆଡେ ଗଲା? ଆବେ ଏବେ ଆଗରୁ ଥଏ ଗୋଟେ ମିନିଟ୍ ସମସ୍ତେ ଦେଖୁଛନ୍ତି ନାଇଁ କିଏ ଆରେ ସେଟା ଅପଲୋଡ ହେଲା ଏଟା ଅଟୋମେଟିକାଲି ଅପଲୋଡ ହେଇଯିବ ଯେତେବେଳେ ଦେଖିନି ନା ପଜ ହେଇକି ଅଛି ଅପଲୋଡ ହେଲା ପଜ ହେଇନି ସେପଟୁ ପୁରା ସେଇପଟ ସାଇଡ ତଳୁ କରିଦଉନ ପୁରା ସେଟା ସେତିକି ତ ଆରେ ଏପଟେ ବୁଲିକି ଯାଅ ଏଇପଟେ ବୁଲିକି ଯାଅ ଦେଖନ୍ତୁ ସେ ଏଇଠି ଛାଡ ପୁଣି ଗଣେଶ ଏପଟୁ ସେଠି ରୁହନି ଆରେ ସେଠି ରୁହନି ସେ ସ୍କ୍ରିନ୍ ଟା ଛାଡି ଦିଅ ସେ ସ୍କ୍ରିନ୍ ଗୋଟେ ଛାଡି ମାମାଲି ସେଠି ରହନି ଆଡକୁ ପଳେଇ ଆସ ମାମାଲି କ୍ୟାମେରା ଫ୍ରଣ୍ଟ ରେ ରୁହନି ଛିଡା ହେଇଛି ଆରେ ଏଠି ସେ ଏପଟ ସାଇଡ କି ଯାହା କରୁଛ କର ସେ ସାଇଡ ରୁ କଟିକି ଏପଟ ସାଇଡ କି ପଳେଇ ଆସ କ୍ୟାମେରାର ସିଧାରେ ହଟି ଯାଅ ସବୁ ଜାଗା ସେପଟ ସାଇଡ ରେ କି ରୁହନି ଏପଟ ସାଇଡ କି ଆସ ବାସ୍ এইপটে মনে করবে এপটে রেখে আসি এদিকে ওটা জানতে করে দিচ্ছি গুণেশ এই গুণেশ ସେପଟେ କି ଜୋନ୍ ଲାଇଟ୍ ଅଛି
ଏଇଠି ବାହାରେ ଅଛି। ଚାଲ ମୁଁ ଯାଉଛି। ଚଳିବ।